Hey guys, welcome back to my YouTube channel mededuphilia. From today and for the next few videos, I will be covering physics. And for physics, I strongly believe that all the chapters are interrelated. So you need to have a clear understanding from the very beginning chapter. So I will be starting from the very first chapter of class 11, units, measurements and dimensions. So firstly, we define a physical quantity. Physical quantity is any quantity that can be measured. This physical quantity can be expressed as n into u, where n is the numerical measure and u is the unit. For example, when we go to a store and when we need rice, we say we need 5 kg of rice, right? So this 5 kg is nothing but the mass of the rice. So 5 is the numerical value and kg is the unit of mass. So hence any physical quantity can be represented as n into u. We can classify physical quantities into two types: fundamental quantities. The second one is the derived quantities. Fundamental quantities are those quantities which are independent of each other, and derived quantities are dependent on these fundamental quantities. So although large number of physical quantities appears in nature, we need only a limited number of units for expressing all the physical quantities, since they are all interrelated with one another. The units for the fundamental or base quantities are called fundamental or base units, and the units of all other physical quantities can be expressed as combinations of these basic units. Such units are known as derived units. So, the units obtained for the derived quantities are called derived units. So there are 7 fundamental quantities, namely length, mass, time, current, temperature, amount of substance and luminous intensity. So the unit of length, as we are familiar, is meter, which is represented as small m. Here we talk about the SI unit, right? And for mass it's kilogram, time second, temperature Kelvin, which we represented as capital K and not small k, and current as ampere, capital A, and amount of substance as mole, and the symbol of unit mole is mol, mole, and luminous intensity, whose SI unit is candela, which has the symbol CD both in smaller case. Apart from these 7 physical quantities, fundamental quantities, we have 2 other quantities which are supplementary quantities. These two are the plane angle and the solid angle, and the units of these supplementary quantities are called the supplementary units, which is radian for plane angle and steradian for solid angle, RAD and SR respectively. So you might have doubt, what is luminous intensity? Luminous intensity is nothing but the quantity, the amount of visible light that is emitted in unit time per unit solid angle. Again, the amount of visible light that is emitted per unit time per unit solid angle. Now let's have a look at the difference between plane angle and solid angle. The main difference is that we represent plane angle in 2D and solid angle in 3D. The normal angle that you use in maths, that is theta, is plane angle, which we represent it in 2D paper, right? Theta can be expressed as S by R, where S is the arc length and R is the radius. So imagine a circle and let the circle have radius R, and say an angle theta is subtended at the center. So this length between the two radii is known as the arc length, which is S, and the length of the radii, the measurement, the value is S, is R. So we represent theta as S by R. So now moving on to solid angle. Solid angle is represented by the symbol as shown, which is omega. Sorry, it's not ohm. And it is the ratio between the intercepted area of the spherical surface described above the apex O as the center and the square of its radius r. So do you see this angle which I have marked in this spherical surface? Yes, this angle is the solid angle. So omega is equal to a by r square. Now let's try to differentiate between plane angle and solid angle. Plane angle's SI unit is radians and solid angle's SI unit is steradian. Maximum value of plane angle, which is theta, is 2 pi because it's 2D, and in a circle we know the maximum angle subtended is 2 pi, that is about its diameter at the center. Alright, now talking about solid angle, the maximum value of omega is 4 pi steradian. Know these conversions where 1 degree is equal to pi by 180 radians. 1 degree is 60 minutes and 1 minute is equal to 60 seconds. So what is 1 degree in minutes? So it is 60 into 60, 3600 seconds. So 1 degree is 3600 seconds. So an important relation between plane angle and solid angle is omega is equal to 2 pi into 1 minus cos theta. You just need to remember this as a formula in your mind and you don't have to look up into its derivation. Now moving on to the second type of quantity, which is derived quantities. Example: velocity, density, charge, magnetic field. So why are they called derived? Because these are all the quantities which are derived from the basic fundamental quantities. For example, when we take velocity, velocity is nothing but distance or total displacement by total time, which is nothing but length by time. Length and time both are fundamental quantities. Now if we take density, density is mass by volume. Mass itself is a fundamental quantity, and talking about volume, volume is length cube, and again length is a fundamental quantity. Similarly, charge, Q can be written as I into T, where I is current and T is time, both of which are fundamental quantities. Similarly, you can try and write magnetic field and force and area into their fundamental quantities. You can break them up and simplify them. Alright, next we move on to the next topic, which is units. So measurement of any physical quantity involves a comparison with a certain basic and arbitrarily chosen and internationally accepted reference standard called unit. So this internationally accepted reference standard is known as unit. So what are the characteristics of a unit? It is a basic, it is arbitrarily chosen, and it is internationally accepted reference standard. So this reference standard is used to measure the physical quantity, and it gives us an idea of how big that quantity is. For example, we are going to buy rice. Okay, just by saying 5, it doesn't make any sense. Are we talking about 5 grams or 5 grains of rice? No, it must be either 5 grams or 5 kg. Okay, so definitely you can see that 5 both are same. Okay, what the difference we can observe is that between grams and kg, 5 grams is very small compared to 5 kg. So it is the unit which is differentiating the amount, the largeness of the quantity, although the numerical value is same. Okay, so in earlier times, scientists of different countries used different systems of units for measurement. So we basically use three systems which are most commonly used, which is CGS, FPS, MKS. CGS is centimeter gram second, and FPS is foot pound second, and MKS is meter kilogram and second for length, mass, and time respectively. So it is here that you need to remember this important conversion, which is 1 kg is 22 pounds. So just make sure you keep this in your mind. So there are different kinds of systems of units used in different countries, but there has to be a system in which conversions within the system is simple and convenient. So for this we use the SI system, which is accepted internationally. So SI is nothing but internationally accepted system of units, which is widely used in all measurements throughout the world. So this is to ensure the uniformity. So as I told you earlier, any physical quantity can be represented as n times u, which is a constant. So we can say n1 u1 is equal to n2 u2. So from this, what do we understand? N is inversely proportional to u, that is the numerical value is inversely proportional to the unit. For example, we say there is 1 kg is equal to 1000 grams. So here itself you can observe kg is a bigger unit than gram, but look at the numerical value accompanying the unit. It's 1 kg. The numerical value is much smaller than the numerical value accompanying grams, which is 1000, which is much bigger. So hence, as numerical value increases, the unit will decrease. Okay. Now let's look at some important conversions which are given in your NCERT. So just try to go through them, and as you keep turning the pages and have a glance every day for just 5 or 10 minutes, and you won't have much strain to remember them in the long run if you continue it. So let's see what they are. Liter, first one. So 1 liter is 1 decimeter cube, or 10 power minus 3 meter cube. And 1 ton is equal to 1000 kgs. 1 carat is 200 milligrams. And 1 quintal, which is used for measuring liquids, is 100 kg. So don't get confused between ton and quintal. Ton is 1000 kg and quintal is 100 kg. Alright. Now make sure to go through the other units as well, and these are some of the commonly used units. And you need to also know about the three special numbers, which is 10 power 26, 10 power 55 and 10 power 17. 10 power 26, 10 power 55, 10 power 17, these are all related to the observable universe. 10 power 26 meters is the distance of the observable universe, and 10 power 55 kg is the mass of the observable universe, and 10 power 17 seconds is the age of the observable universe. So you just try to remember them. You don't have to remember all the values given in NCERT, just these special values will do. And nextly, we have three important units for length. First one being astronomical unit. So what is one astronomical unit? 1 AU or astronomical unit is the average distance of the sun and the earth. Okay, and the value of it is approximately 1.5 into 10 power 11 meters. The next important unit is 1 light year, which is 9.5 into 10 power 15. So I am rounding it off to just one decimal place so that it will be easier for you to remember, and based on the options you can choose. So what is 1 light year? So the very term light year, we should not get confused that it is a unit of, or it is a term used for time, just because there is a year in the term. So light year is nothing but the distance that light travels with the velocity of 3 into 10 power 8 meter per second in 1 year. Okay, so this is the basic definition of a light year. So light year is not a unit for time, but it's used for length, to measure length. Okay, the next important is parsec. Okay, so let's see what is 1 parsec. 1 parsec is the distance at which the average radius of Earth's orbit subtends an angle of 1 arc second. So let me draw for you. Before that, the value of 1 parsec is approximately 3 into 10 power 16 meters. So here is the earth, and now I'm drawing its orbit, and we have the sun at the center, and this distance between the earth and the sun is nothing but 1 AU. But here we take the sun at the center, so this distance is nothing but the radius of the orbit of revolution of earth around the sun. Okay, so now when the angle this sub the average radius of the earth's orbit substance is equal to 1 second, one arc of a second. So when this angle becomes 1 second, then this distance which I am marking here is nothing but 1 parsec. Alright. Now let's move on to the next topic, which is dimensions. So dimensions are the powers to which the fundamental quantities or fundamental units are raised in order to represent the physical quantity. Okay, so let me give you an example. Let's take force. Force is mass into acceleration. So what can acceleration be written as? Change in velocity by change in time. So velocity can again be written as length by time. So there's an already a t in the denominator in acceleration term. So it becomes length by time square. What are we doing? We are actually bringing the term into in terms of the fundamental quantities. That is our aim. Okay. So when you solve, it will be you will get m l t power minus 2. So this thing what we have got here is nothing but the dimensional formula. Okay, so what is dimensional formula? Expressing a given quantity in terms of the fundamental quantity, fundamental units. This is known as dimensional formula. Alright. So we have successfully established a fundamental formula for force. So what do you mean by dimensions now? Can you see the powers of m, l, t? Yes, that is 1 on top of m and 1 on top of L and minus 2 on top of T. Yes, these powers are nothing but the dimensions. So I hope you have clearly got the idea and the differentiation between dimension and dimensional formula. Alright. So when I ask students what is the dimensional formula of force, it's correct to say mlt power minus 2. But when I ask what is the dimensions of force, you should tell me that it is 1 comma 1 comma minus 2 and not mlt power minus 2. That becomes the dimensional formula. Alright. So using the same method, we can find out the dimensional formula, volume, acceleration, momentum, work, power and other physical quantities. So we will practice it separately in another video where I'll be doing only questions. That is all kinds of possible questions that could be asked from this chapter. So in that video, I will solve many examples for dimensional formula. But it's easy to get. I think even one example is sufficient for you to understand. Now let's see what are the applications of this dimensional analysis method. The first one is to check the correctness of a given equation using the principle of homogeneity. So what is this homogeneity principle? We'll see. Then the second one is to derive a relation between physical quantities. Okay, what do you mean by checking the correctness of the given equation? Okay, is to check whether the given equation is dimensionally correct or not. First of all, let's take an example. Say I give you a random equation like this. V is equal to under root T by AD. Okay, where T is the tension, A is the area, D is density and V is the velocity. Okay. Now what we have to do is to check the correctness, check whether the given equation is correct or not. So for this we use homogeneity principle. So what we do is we find out the dimension of the physical quantity given in the left hand side and we find out the dimensions of the physical quantity by simplifying the terms given in the right hand side. If both are equal, if both the dimensional formula are one and the same, then we say that LHS is equal to RHS and so the given equation is dimensionally correct. So let's try out and work out this problem which I have given now. Let's take LHS. What is the dimension formula of velocity? Here we commonly say 5 meter per second, 25 meter per second, right, for velocity. So velocity is nothing but total displacement by total time. So it is L length and length by time. So the dimensional formula will become LT power minus 1. So left hand side is simple and it's over. Now we'll move on to right hand side. Now the first thing we see is T. Tension is nothing but a kind of pulling force. So it will have the same dimensional formula as that of force, which is mLT power minus 2, which we've already discussed. Okay. And the dimensions of area is length square, side into side, which is length square. Okay. And density, dimensions of density is nothing but mass by volume, so it will be m by L cube, that is ml power minus 3 is the formula, dimensional formula for density. So the very first step for solving any question is to write all the quantities dimensional formula, okay, and then to solve them based on the operation, whether it's division, multiplication, addition, subtraction, whatever it is. Now we find that it is T by AD. So we have to write the dimensional formula as such. So it will become ml T power minus 2 by L square into ml power minus 3. So on cancelling the same terms, what do we get? T power minus 2 by L power minus 2. So it becomes, taking L power minus 2 to the numerator, it becomes L square T power minus 2. So remember, there is a whole under root. So taking square root of this, it becomes LT power minus 1. Now compare this with what we got in LHS. Now do you see both are same? So can we conclude that this equation is correct, is dimensionally correct? Yes. So how they will test you in NEET is that they will give you question like which of the following option is incorrect. So they will give you a set of options in which you will have different formulas. So in that case, you will have to check all four options whether they are dimensionally correct or not. Okay, for that you need to be really fast and you need to improve your speed and accuracy. Alright, next we move on to the second one, that is second application, that is deriving the relation between physical quantities. Let's see. So how do we check this? So they will give you in the question that a certain physical quantity depends on other physical quantities. They will list out the other physical quantity on which it is dependent on. Now we have to find out the relation between all the physical quantities given in the question. Okay, so let's practice a question so that you'll understand. I give you a question that goes like, viscous force depends on radius r, coefficient of viscosity neta, and velocity v. Take constant of proportionality 6 pi and derive the relation between force of viscosity, radius, coefficient of viscosity, and velocity v. So in all questions, what do? Always try to write the dimensional formula of all the physical quantities given in the question. So force, we know it is mLT power minus 2 and radius is nothing but length. So it is just L. And talking about coefficient of viscosity, you will learn in the chapter known as fluids. You learn a separate formula, and from that formula you can obtain the dimensional formula of coefficient of viscosity. For now, just remember it is ml power minus 1 t power minus 1. Okay, so I recommend you to remember this part, that is the dimensional formula of coefficient of viscosity, because this is extremely important and it has been repeated multiple times in previous papers. Okay, and it's easy to remember also. Okay, so next we write the dimensional formula of velocity, that is L t power minus 1. Length, displacement, total displacement by total time. Okay, so when you know the formula of each of the quantity, you would have definitely come to know the dimensional formula. So don't worry that at one stage you might not be even heard of the term coefficient of viscosity or magnetic flux. You might even not know what they are, but when you complete your NEET preparation, that is when you complete class 11 and 12 syllabus, you will be familiar with all the physical quantities and you will know all the formulas, so it will be easier for you to write the dimensional formula. Okay, now we assume that F is equal to k times some constant into r power x, neta power y, v power z. Why are we doing this? Because they have given force depends on radius, coefficient of viscosity and velocity. But we do not know how it depends. That is, we do not know the dimensions x, y and z which we have to find. So we are equating like this. Now what should we do? They have given the constant of proportionality as 6 pi. So you should simply substitute the dimensions of force, neta, radius and v. Then what should you do? When they are getting multiplied, the powers will get added. So it will become L x minus y plus z and m power y t power minus y minus z. Now what you do is equate LHS and RHS. So in LHS it is m power 1. So you can equate y and m. So y is equal to 1. Similarly equate the powers of L. So there is 1 in LHS. So you can equate 1 is equal to x minus y plus z. Similarly for powers of t, minus 2 is equal to minus y minus z. So what you can do is substitute the value of y here in the third equation and you will get the value of z as 1. So now you can substitute the value of y and z in the second equation. We will get x as 1. Okay. So now we have found out the dimensions, that is the value of x, y and z which are all equal to 1. So what do we get the formula as? F is equal to 6 pi r power 1, neta power 1, v power 1. So the formula is F is equal to 6 pi neta rv. So this is you will learn this as a formula itself in fluids. Okay, so when you know that this is a direct formula that you've already learned, then definitely it will be dimensionally correct. You don't even have to check in the later stages I'm talking about. But in the initial stages, don't always try to learn the procedure of what we are doing here. Okay. Now in this question they have given the constant of proportionality is equal to 6 pi. What if this constant is not given? We would have found, okay, that it is depending on r, neta and v as r power 1, neta power 1 and v power 1. But can we is it possible for us to find the actual formula of force of that is viscous force? No, we couldn't have found the actual formula. We can only find the dependency on the variables. Okay, but we couldn't have found the actual formula. Only because they have given we can find. So this becomes a limitation for us. Okay, the actual equation, the correct equation cannot be found by this method of dimensional analysis. Now okay, and there is one more application of dimensional analysis is that to convert the physical quantity in value into one system of units to another system of units. Let's see how we can do it. Okay, let me give you an example. Find the value of force in CGS system. This is the question. Okay, so what we should do here is we are applying a simple formula which we learnt before, that is N1 U1 is equal to N2 U2. So this is a standard formula which we use for converting from one system of units to another system of units. So here what are we doing? We are basically converting force which is an SI system into CGS system. Simple? Yes. So what should we do? Firstly, write the physical quantity, write the dimensional formula of the physical quantity given in the question. So force, it is mLT power minus 2. It is kg meter per second square, right? What is the SI unit of force? It's Newton, right? So it's kg meter per second square, mass into acceleration. That are they are the units of force. So we have to find the value of 1 Newton in CGS system. So N1 is 1 and U1 is kg meter per second square is equal to N2 is what we have to find. We have to find the value of force in CGS system. So that is what we have to find. So N2 into, what are the units of force in CGS system? It will become gram centimeter per second square. Am I right? Yes. So in the LHS we have to convert everything to CGS, right? So what are we doing? we write 1 kg is 1000 grams, so it becomes 1 into 1000 grams into 1 meter is 100 centimeter. 100 centimeter, seconds are getting cancelled, okay, is equal to n2 into gram centimeter. So we get the value of n2 as 10 power 5. So the SI unit is of force is Newton and the CGS unit of force is dyne. So what can you conclude from here? 1 Newton is equal to 10 power 5 dynes. So please remember this. This will be asked in other types of questions also. So even if you forget what is like how much is 1 Newton, how much dynes is 1 Newton, you can find out by this method. So isn't this really helpful? Alright. Now I will give you another question. You have to pause the video. It is little different model compared to the first question. Pause the video and try to solve it on your own. Okay. The question goes like, convert 1 megawatt power to a new system. Okay, no, it's not CGS or it's not FPS, FKS or anything. We are converting into a new system. Okay, having basic units of mass, length and time as 10 kg, 1 decimeter and 1 minute. So how will you do this question? Pause the video and try it out. Okay, so the first step is writing N1 U1 is equal to N2 U2. So that is the basic formula. Uh, and based on that, we proceed the whole sum. And what is 1 megawatt? That is the physical quantity given in the question. And we have to attempt to write the dimensional formula of that physical quantity. Okay, so 1 megawatt is nothing but 10 power 6 watts. And watt is the unit of power. And power is nothing but energy by time. And energy is nothing but force into displacement. Yes, energy is same as work done. Yes, so it becomes dimension formula will become ml square t power minus 2 by t, that is the t in the denominator for power. So solving you will get ml square t power minus 3 as the dimensional formula of power. Okay, now we have to convert this 1 megawatt into the new system of units. We have to find the numerical value. So that 1 megawatt we can write as 10 power 6 into. So we got ml square t power minus 3. So just take the SI system. Okay, always take the SI system because we're more familiar with it and it can be easier for solving. And we can solve faster also. So take kg into meter square because it's L square into second power minus 3 is equal to N2 into 10 kg into 1 decimeter. So this decimeter is the length, unit of length given in the question according to the new system of units. What is our job is to convert everything into SI system so that things will become easy for us and we can cancel the units on both the sides. Okay, and we can get the value of N2 alone. So we have to find the relation between 1 decimeter cube and 1 meter. So we all know 1 decimeter is nothing but 10 power minus 1 meter. Small to big we have to divide. Millicentidecimi deca hecta kilo. Okay, I think you know this. So you just have to write the value of 1 decimeter in meters into they have given 1 minute. 1 minute is nothing but 60 seconds. 60 seconds the whole power minus 3. Now what should you do? Open the brackets and solve the powers and you should solve this entire thing. Okay, so it becomes 10 power 6 kg meter square second power minus 3 is equal to n2 into solve this you will get 10 into 10 power minus 2 by 60 into 60 into 60 because it is 60 whole power minus 3, right? So when you solve this, what will you get? The units are going to get cancelled. So you will get 10 power 6 is equal to n2 into 10 power minus 4 by 216. 6 into 6 into 6 cube is 216. Okay, so you will get n2 as 216 into 10 power 10. In writing it in scientific notation, we will get N2 is equal to 2.16 into 10 power 12 in new system of units. Okay, I hope your answer matches with mine. Yes? Okay, So now let's talk about the limitations of dimensional analysis. One, we've already discussed in in the second application itself, that the proportionality constant cannot be found, and only if this proportionality constant is found, we is given, we can actually find the actual equation, the correct equation of the dependency of physical quantities. Okay, the second limitation: equation of a physical quantity that depends on more than three independent physical quantities cannot be found. Okay, so here last previous question we got f is equal to 6 pi neta rv. Yes, here exactly there are three quantities. Okay, so it can be found. Okay, but more than three, it cannot be found. The equation we cannot find by dimensional analysis. Third one, which I would say is the most important, that is the equations containing trigonometric, log, and exponential functions cannot be derived, as they are all dimensionless. Trigonometric, log, and exponential, all these functions are dimensionless, hence they cannot be derived. So based on this single point, you might just ignore it as thinking that this is just a theory point, you just have to remember, but no, you will be tested. How? Let's take an example. In SHM, you will learn this equation: x is equal to a sine omega t. So, what did I tell you? The trigonometric function is dimensionless. So, this omega t is dimensionless. So, this example is simple. So, we already know that omega is nothing but the angular frequency. Angular frequency is equal to 1 by 2 pi t, where t is the time period, and is already a t in the numerator in omega t. So the t, both the t will get cancelled. So omega t, this whole thing will become dimensionless. So that's why I told you trigonometric functions are dimensionless. So the dimension, what is the dimensional formula? M power 0, L power 0, T power 0, which is simply dimensionless. Now I'll give you a question, which is n is equal to n naught e power minus lambda t. So this you learn it as a formula in radioactivity chapter. Okay. Now my question is, find the dimensions of lambda. What is the dimensions of lambda? Very easy. Tell me. Yes. So this e, you can see, you can directly find it out. This is an exponential function, hence there is no dimension. So this t and this dimensions of lambda should get cancelled out. So obviously lambda should have the dimensions t power minus 1. Okay, so it's as simple as that. Okay, next we move on to the fourth point, which says that for a given dimensional formula, the physical quantity is not unique. This means that for one particular dimensional formula, there can be more than one physical quantity. Okay, which means I'll give you an example. Say work, heat, torque, all these have the same dimensional formula as ml square t power minus 2, because they're all nothing but force into distance or displacement. See, work again is force into displacement, and when you take torque, torque is also for r cross f, right? So when you solve them, you will get the dimensional formula as ml square t power minus 2. So all of them have the same dimensional formula. Now let's look at some important points. The first one, pure numbers do not have dimensions. Yes, when you say 5 pence, yes, this 5 does not have any dimension because it's a pure number, right? Okay. Second one, only quantities with same dimensions can be added or subtracted. So here the principle of homogeneity is important. So you should, using the principle of homogeneity, you should check whether all the given terms in the question are of the same dimensions or not. Only if they are of the same dimension, they can be added or subtracted. Third point, dimensions of a physical quantity does not depend on the system of units. So this is a good point which you can expect in an MCQ. So how do you understand this point? So force, whether you take in SI unit, Newton, or CGS unit, Dyne, the dimensional formula and the dimensions, it is same as ml t power minus 2, which is 1 comma 1 comma minus 2. So that is going to remain the same. So hence that dimensions of the physical quantity does not depend on the system of units. All right. So now we are going to the next topic, which is about significant figures. So significant figure is nothing but the total sum of certain digits plus uncertain digits in a given number, in a given measurement. Okay, for example, we take a measurement, that is, I'll give you a book. Okay, say we are measuring the physics textbook, NCERT physics textbook, and I tell you to measure it in scale. So although the length of the book is same, some people will take the measurement to be different. Okay, each person will get different value by just one decimal point or 1 point. For example, say it is 25 centimeters. Okay, so one person can get 26 centimeter, one person can get 27 centimeter, right? So this last digit, you see, that is differing, so that digit is not certain, it's doubtful. Okay, so and the first digit we are sure it's about 20, it's about 20, so that 2 is a certain digit. So in this measurement 25, so what the total number of significant figures is 2. So it is nothing but the sum of certain digit or sure digits plus the next doubtful or uncertain digit. For example, when you take 2, 3, 5, 7, 8, just random number, so the last digit becomes uncertain and the rest few become certain or sure digits, right? So the total number of significant figures is what? 1, 2, 3, 4, 5. Yes, it's 5. So the answer here is 5. Now let's look at the rules for finding significant figures. Firstly, all non-zero digits are significant. As I told you, the example I gave you, 2, 3, 5, 7, 9, 8, and any number, when the numbers are not zero, then you can blindly tell that all these digits are, all non-zero digits are significant. Second point, all zeros occurring between two non-zero digits are significant. So when you find a zero between non-zero consecutive non-zero numbers, then definitely they are significant zeros. So here you can see there are three significant zeros in 2, 3, 0, 5, 0, 9, 0, 8. Okay, and tell me the total number of significant digits. All the digits here are significant, so there are 8 significant figures. Okay, now let's move on to the third point. All zeros to the right of the last non-zero digit are not significant. Here let me take an example, 590000, 4 zeros. Now tell me, are these zeros significant or not? No, they are not significant. So there are 0 significant zeros. Getting the point? And what is the total number of significant figures? 5, only 5 and 9. Okay, so 2 significant figures. I hope you have understood. All the zeros to the right of the last non-zero digit are not significant. Alright. Fourth point. In a number less than 1, all zeros to the right of the decimal point and to the left of a non-zero digit are not significant. Now I will give you an example. For example, take the number 0.000158. Okay, so these zeros which you see to the right of the decimal point, okay, which is to the left of the first non-zero digit, these are all insignificant. Getting the point? So all zeros to the right of the decimal point and to the left of a non-zero digit, they are not significant. Understood the point? Okay, now I'll give you a question. Find the number of significant figures in this number, significant zeros. Okay, not significant figures, significant zeros. So the now question is 0.001501250001200. So tell me, what are all the significant figures, significant zeros here? The first zero here, 1501. So it's between 5 and 1. So it's between two non-zero digits. So it is significant. Similarly, the zeros between these two zeros between 5 and 1, they are also significant. And the last zeros are also significant. That is our fifth point, I'll tell you. So just for now, know that the last two zeros are also significant. And the first two zeros, because they are just to the right of the decimal point, they are insignificant. So tell me, how many significant zeros are there? What is the answer? It is 5. So there are 5 significant zeros here. Next, the fifth point. All zeros to the right of a non-zero digit in the decimal part are significant. Okay, so the same example I told you, 0.15000. So these three zeros are all significant. Now you might have a doubt, why are they significant? What is the importance? Okay, for example, screw gauge, take vernier caliper, so that can measure up to only one decimal point. Only the least count is 10 power minus 1. Whereas screw gauge can measure up to two decimal points. That is that much accurate and precise. So it can it is used better to measure. So we say even the last digits matter a lot. So from this value, that is 0.15000, this measurement is say from some device X. So we can observe that this device X is capable of measuring up to how many decimal points? 1, 2, 3, 4, 5 decimal points. So these zeros in the end do matter a lot. This will give you the precision of the instrument. Okay, the number of decimal points it can measure up to, that is very important. Hence we say that the decimal these zeros that is to the right of the non-zero digit are significant. Okay, so be careful with the rules. You might the only confusing part will be in the zeros thing. Okay, which zeros are significant and which zeros are insignificant. So you need to just have a look at these rules again, and it's easy to understand. You will understand it easily, don't worry. Okay, now let's look at the arithmetic rules. How the final result will vary according to the rules of significant figures. In addition and subtraction, the final result should retain the least number of decimal places as in the individual values. Whereas when we talk about multiplication or division, the final result should have the least number of significant figures. Do you know the difference? Addition and subtraction is least decimal places, and for multiplication or division is least significant figures. So I'll give you a question. Say you have to add 0.15 and 0.239. So add and tell me what do you get. So here we are getting 0.389. So in the individual values, that is 0.15 and 0.239, the one which has the least number of decimal places is 0.15, which is only two decimal places. So the final answer should also have only two decimal places. So we should round off the final result up to only two decimal places. So rounding off, you will get 0.39. I'll explain the rules of rounding off in the later topic. Okay, the next topic is that only. Okay, now let's take a question for the second point. For example, I take 2 into 400. What do you get? 800. So do you have to make any changes here? No. Why? Because 2 also has only one significant figure, and 400 also has only one significant figure. These trailing zeros are not significant because it's a number greater than 1. Okay, for a number greater than 1, not a decimal number, the trailing zeros are not significant. So the final answer 800. Again, it also has only one significant figure. So this is the correct answer. You can just leave it like that. Now let's take another question. 6 into 0.12. So 6 has one significant figure. Okay, here you should look at the number of significant figures and not the number of decimal points. Okay, decimal places. Okay, then in 0.12 you have two significant figures. This is 1 and 2. So what do we get on multiplying? You will get 0.72. But the final answer should have only one significant figure, so we should round off. Am I right? So round it off to one decimal point. So just chop off the 2, you will get 0.7, which has only one significant figure, which is the answer. Now, can you see the point which I have typed it down in red? Significant figures do not change when the physical quantity is measured in different system of units. This we already saw in the important points part. Okay, what did we see there? That the dimensional formula is same whether the physical quantity is measured in CGS or SI. Same way, significant figures also do not change when the physical quantity is measured in different system of units. Okay, so keep this point also in mind. Now let's look at the rules for rounding off. So for this, you should just remember this trick, ensure even. Okay. So for numbers equal to or greater than 5, what should you do? You should think about adding 1, whether if it's odd. Okay. If it's even, yes, ensure even. You can just leave it same. But if it's odd, you should add 1 to the previous number. Okay, I'll give you a question for you to understand. For example, I take 6.997. You should round it off to 2 decimal places. Now, this 7 is a number greater than 5. So, you should definitely look at the digit next, that is previous digits. So 9. So this 9 is odd. So what should you do? You should add 1 because it's greater than 5. If it's less than 5, no problem. Just leave it as that. You don't have to even look at the previous number. You can just chop off that number and the final answer you will get. But here it's greater than 5 and the previous digit is also add. So you need to add 1. So when you add 1, what will you get? Add 1 to 9, you will get 7.00. Okay, now let's look at the second question. So I give you a number 7.4850 and you should round it off to 2 decimal places. Now what should you do? There is a 5 after 8. So equal to or greater than 5, what should you do? You should look at the previous digit. So the previous digit is 8 and 8 is even. So no problem at all. Ensure even. So the final answer will simply be 7.48 and that's it. Understood? Now, okay, I'll give you another question. 6.755000. Okay. Now the trailing zeros, you can just leave it off. Okay. We have to just round it off to 2 decimal places. So there is a 5 over here. And it is anything greater than or equal to 5, you should look at the previous digit. And the previous digit is odd. So what should you do? You should add 1. So what is the answer? 6.76 is the answer, the final rounded off answer. Now we are moving on to the next topic, which is order of magnitude. So with this order of magnitude, we can find out how big or small the quantity is. Okay. For our large distances, we usually say, for example, we learned universe, the age of universe as 10 power 17 seconds. We do not know that 10 power 17 is not the exact value, right? So we, for large distances, the order of the magnitude, and for very small distances also the order of magnitude becomes important. Okay, so what is the trick to find order of magnitude? So just look at the numerical part. First, always write the given question in scientific notation. And next what you should do is look at the numerical part. If the numerical part is less than or equal to 5, then it's the same. If it's more than 5, then the order of magnitude you should add 1 to the power. So first, expressing it in scientific notation, see the numerical value first, the number part. Okay, if it's greater than 5 or less than 5. Okay, if it's less than or equal to 5, then the order of magnitude, that is the power value which is on top of 10, that will remain same. If it's more than 5, you add 1. Okay, let me give you an example. Take the number 32678. First step, writing in scientific notation. So it becomes 3.2678 into 10 power 4. I hope all of you know how to write in scientific notation. Okay, so look at the number part, it's 3.26 so on. So this 3 is 3.2. Okay, so this is a number less than 5, so you don't have to do any changes. The order of magnitude is just the number which is on top of 10. You write it as such. So the answer is 4. Now let's look at the next question. Take the number 999999999. Okay, first what should you do? Express in scientific notation, you get 9.9999 into 10 power 4. So this number 9.9999 is a number greater than 5. So what should you do? Add 4 to the number on top of 10. So what is the order of magnitude of the given number? Yes, it is 5. So the answer is 5. Let's you try out this question. Pause the video and try out. 8. For the number 8, what is the order of magnitude? Yes. So write it in scientific notation, 8 into 10 power 0. This is how you write in scientific notation. And this 8 is a number more than 5. So what should you do? Add 1 to 0. So the answer is 1. Okay, so I hope I've done my best to make you understand every concept, and we've almost completed half of the chapter, and the rest of the chapter, that is about errors and vernier caliper, screw gauge, and problems related to that will be covered in the next lecture. And I will be taking another video for covering all the types of questions in a separate video. That will be the third part of this chapter. Okay, so the first part comes to an end here. So show some love by hitting on the like button and subscribe if you had understood the concepts clearly. Thank you so much, and let's meet soon in our next video.